Hello everyone, welcome to my video. Today I'm going to show you the new feature I added to the etracer control software. Previously I decided to freeze all the features for a version 2.x, but according to the recent discussion on Facebook, I think a new feature is helpful to nice to have for this release, so I decided to add another feature to the software 2.x. Okay, so the new feature is the corner cases, the test for corner cases, and the reason I designed this test is based on the test result in Bangkok 2 weeks ago. So let me show you the problem. Okay. Okay. So in Bangkok, I measured a lot of tubes, including several types of 300B. So here I measured two 300B dark glasses from Pisfan. And this is the first tube I measured. So as you can see, each curve is spaced nice and evenly. So if we pick a typical operation point for 300B, that would be 385 on the plate. I don't know, maybe 90 milliamp on the plate current at a yeah, that's pretty much about it. So here we have a grid voltage at the -70, and if we lock the load resistance to 2.5K, we get the maximum output of 9 watts with a THD of 5.8%. So this is pretty much the work point chosen by Audio Node Kit 1. Okay, so here is another tube I measured, the same type but different tube. Okay, so I think you can see the difference clearly. These curves starting from minus 100 on the grid, the curve raised much earlier than the previous one. So you can see the curves are like the space between these curves are not spaced evenly as the previous one. And the problem with that is if we use the same operating point with a current of 90 mm and the load resistance of 2.5K. Okay, and as you can see, we get much less output. And if you remember, the previous curve gave us 9 watts with a distortion around below 6%. But with this tube, you get less power and much higher distortion because the unevenly distributed curves. So if you compare the solid bar and the length of the solid bar to the length of the dashed bar, you can clearly see the wave is asymmetric. So this kind of problem cannot be captured by other tube testers. So the test I added is trying to catch this kind of tube failure. So the idea is we can set a criteria. For example, if we want to capture the problem with this tube, we can configure, say, a plate voltage of 450 volts, for example, and the negative grid voltage of -40, and we set the criteria at this operating point, we shouldn't see a current above more than 5 milliamp. So if we set out this condition, then we can capture this kind of fault easily. So here I show you how to do it. And in this corners tabs, I have 4 tests. So you can enable one of them or all of them or combinations thereof. And so we can type in 400, 450 here. And since it's a triad, we don't use HTTP2, so we can leave HTTP2 as is. And negative voltage of -40. And this is a current criterion. So we say the criterion HV1 current has to be lower than 5 milliamp. And if we click run, of course we need to turn on the heater first. Then we can check the result here. Since I don't have this faulty 300B, this belongs to one of my friend in Bangkok, so I cannot run the test. But you get the idea. So next, I'm going to show you other use cases for this kind of test. So now we are going to use the 12X7, for example. Okay, so here is the measurement data for a 12X7. So if we check the quick scan result, we can see the measuring point is at 250 volts on the plate, and with the negative voltage of -2 volt. And the reference current is 1.2 milliamp. So if we want to select tubes, or we want to I don't know, match tubes. So one criteria we might want to add is the at this operating point, the measured current should not fall below 1 milliamp. So we can dial in that test case. Let me turn on the heater first, because we are going to measure to run the test. So at 200, and we can since it's a twin triad, we can apply this criteria on both sections simultaneously. So let me reset the curve. 250 negative of 2 volt, and the criteria is the measured currents has to be above. So the criteria is both section has to be the measured current has to be above 1 milliamp. So this is the first condition we want to test, and we can configure other cases. For example, the major current shouldn't go above something, because for example, I observed some faulty tubes. If you apply a too high a plate voltage, you will see a sudden jump in the measured current. That's because the at higher voltage, the impurity inside the tube create a conducting path from plate to ground directly, and that kind of fault you can also capture it here. Okay, so now we are ready to run this test. Okay, as you can see, testing and failed. Why it's failed? Because the red section, the left curve, the major current is below 1 milliamp, and the section indicated by the green color measured above 1 milliamp. But this is the end condition, so both criteria has to be made. If we say we don't measure, we ignore the section indicated by the red color, and we run the test again, we'll see a pass because we don't compare this section. Okay, you can add, when you edit this test condition, you can save it back to the tube configuration file. And I think this is quite a unique feature only for etracer, because to capture this kind of fault, you need a very high measuring voltage, like 450 volt, 500 volt, or even higher. And your negative voltage has to be high as well. And so I think this is probably the first machine, the only machine that's available now that can capture this kind of fault. Okay, enough for advertisement. Thanks for watching my video. I'll see you next time. Bye bye.